So this question is a simultaneous equation that we have, and we're told to find the value of A and B, and we are supposed to use matrices. Okay, so you can use Cramer's rule to solve this one. It's possible, but there is another way to do it. This is where you find the inverse of a matrix. Okay, so let's go ahead and do that. First thing you need to do, just like with Cramer's rule, you need to have all your variables on one side, and on the other side you have your constants. So the first equation is already like that. You can see all my variables A and B on that side, but in the second equation I have some variables on the other side. So what I will do is collect them. Now this one here is a fraction. The denominator is A, so I can break it up so that I have only I have two separate fractions rather. And if I do that, I will have 6 over A minus 1 over B. This is equals to A over A plus 4 over A. Okay, and we know that A over A is just equal to 1. Okay, so this 4 over A, I could bring it over to the other side and then rewrite this equation as it's 2 over A minus 1 over B, and this is equal to 1. So these are the two equations that I essentially have. So it's those two over there. Okay, and I have to solve them. Now to do that, all I have to do is write it in matrix form. Then I label my matrices A, X, and B, find the inverse of matrix A, and then multiply that on both sides. So here, it might be tempting to try and rewrite these equations where you have A and B in the numerator. You don't have to do that. Your variable can be 1 over B. If you know what 1 over B is, finding B is not difficult at all. So to do that, what I will do is I will rewrite this one as 2 multiplied by 1 over A plus 3 multiplied by 1 over B, and then this is equal to 13. And then this one over here, I can rewrite it as 2 multiplied by 1 over A minus 1 times 1 over B. The 1 is not really necessary, but there it is. Okay, so I can rewrite them like that, and then you can see that my variables are 1 over A and 1 over B. Then I write it in matrix form. Now remember, in matrix form, I have a matrix of my coefficients. So it's 2, it's 3, it's 2 again, and then it's minus 1. So all these coefficients, and notice this is the column of X, that is the column of Y. All these are variables of X, 1 over A, I'm used to A and B, X and Y rather, and then those are the variables of the coefficients of 1 over B. So I have 2 and 2, which are my variables of 1 over A, and 3 and minus 3. And here I would multiply this by 1 over A. This is the first one, so it's this times that. And then this one would multiply 1 over B. And this is all equal to my constants over there. Okay, and this makes sense because I have a 2 by 2 matrix. This is a 2 by 1 matrix. If I draw my rectangle over here, the numbers inside the rectangles are the same, so matrix multiplication between those two is possible, and my solution should be a 2 by 1 matrix, and you can see this is a 2 by 1 matrix, so I've written it correctly. Any other order, if I put this one on that side, matrix multiplication would not even be possible. Okay, so now that I have that, remember what I need to do is find the inverse of this matrix. Now remember, the inverse of a matrix is a matrix that when I multiply it with the original matrix, I get the identity matrix. Now the identity matrix is just a diagonal matrix with ones on the leading diagonal. Now finding the inverse of a 2 by 2 matrix is very simple. There are a few steps that you have to follow. With bigger matrices, there's it's not the same procedure of just switching elements and changing the signs and something like that. So it's a little bit more complicated. But for a 2 by 2 matrix, not much to do. Okay, so now that I have my matrices, I'm just going to make some space and find the inverse. So here I've written, this is my matrix A, that is my matrix X for my variables, and this is B. So I have A times X is equal to B. Now what I need to do is find the matrix A inverse. Then when I multiply A and A inverse, I get the identity. And what I do on one side, I should do on the other side. Now I'm going to multiply A inverse over here. So I'll put A inverse over there. I do not put it on this side, because if you remember, matrix multiplication is not commutative. Commutative just means the order you put them in matters. Because with numbers, when I'm multiplying them, I say 2 times 3, I get 6, and then I say 3 times 2, I still get 6. So it doesn't matter whether 2 came first or 3 did, the answer was still the same. But with matrices, if I have A inverse times B and I compare that with B inverse times A, if the multiplication is even possible, most of the time the answer you get will not be the same. Okay, so I need to find this A inverse. And if you remember, A inverse, we said we need to get the determinant of matrix A. So determinant of A for a 2 by 2 matrix, very simple to do. You find the product on the leading diagonal minus the product on the minor diagonal. So I will say 2 times minus 1. So it's 2 times minus 1. And then I subtract the product on the minor diagonal, which is 2 times 3. You can check that on your calculator, but you shouldn't need your calculator for this. This is minus 2 minus 6. Minus 2 minus 6 is equal to minus 8. So that is my determinant. So I know my matrix has an inverse because this determinant is not equal to 0. So your determinant determines if your matrix has an inverse or not. If the determinant is 0, then no inverse. If your determinant is anything else except 0, then it has an inverse. Then this determinant, I will use it to work out A inverse. So this is the formula. So I say 1 over my determinant, so it's 1 over negative 8, and then I multiply that by a matrix that I'm going to put over here. Now this matrix, I derive it from A. Now to do that, on the leading diagonal, I interchange the elements. So I put minus 1 here, and I put 2 there. So you can see this minus 1 is on top. In A, it was below. Minus 2 is there at the bottom. Now there it was at the top. Okay, and then with these ones on the minor diagonal, I multiply them by minus 1. So it's 3 times minus 1, it's negative 3. 2 times negative 1 is negative 2. Now when I multiply the scalar with this matrix, what I will have is my A inverse. Okay, so there it is. All we have to do is multiply the scalar inside. Should multiply every term in there. Okay, and when we do that, this is what we get. Negative and negative gives me a positive 1 over 8. Negative and negative is positive 3 over 8. And then negative and negative, again this is positive. So I'll just write this one as positive 2 over 8. You can go ahead and simplify it, but they're exactly equal, so there's nothing wrong with that. And then negative and positive, this one gives me negative 2 over 8. Okay, so now that I have the inverse of the matrix, what I will do is I will multiply it by bx on the left, and also by, I'll multiply it by ax on the left hand side, and also by b on the right hand side of the equal to sign, but on the left of b. So this is what I will have. A inverse will go over here. I will have 1 over 8, 3 over 8, 2 over 8, and then minus 2 over 8. And then my matrix A, it's 2, 3, 2, and minus 1. My X matrix, which is just the matrix of coefficients, I have 1 over A and 1 over B. And then doing the same thing on the other side, I have A inverse, so it's 1 over 8, 3 over 8, 2 over 8, and negative 2 over 8. And then this is multiplied by the solution matrix or the constant matrix, which is 13 and 1 over there. Okay, so I did the same thing on the left hand side and on the right hand side. I multiplied A inverse on both sides and I put A inverse on the left, and I did the same thing over there again because matrix multiplication is not commutative. So what I will do is I will multiply these two together and then see what we get. It should be the identity if we've done the finding of the inverse correctly. And you know how we multiply? It is row times a column. So doing that, I'll have 1 over 8 times 2, it's 2 over 8. And then I have 3 over 8 times 2, this is 6 over 8. That was first row, first column. Then I move to this element over here, which is first row, second column. So I have 3 over 8, which is 1 over 8 times 3. Then I have 3 over 8 times negative 1, which is negative 3 over 8. Then same thing in the second row, first column. So it's second row, first column. I have 2 over 8 times 2. This is 4 over 8. So again, you can simplify them, but I prefer not to. This negative 2 over 8 times 2. This is negative 4 over 8. And then second row, second column. Second row, second column. I have 6 over 8. That's 2 over 8 times 3, and then negative and negative will give me a positive 2 over 8. Okay, so I've multiplied these two. I'm still left with this 1 over A and 1 over B. These are my variables. And then on this side, I should also go ahead and multiply the row with the column. I didn't mention it, but I do know that they are compatible because this is a 2 by 2, this is a 2 by 1. When I draw my rectangle, 2's will be inside the rectangle, so they are compatible to be multiplied. So I'm doing the same thing. I multiply row with a column. So I will have 1 over 8 times 13. This is just 13 over 8. And then 3 over 8 times 1. This is just 3 over 8. Then the second element here, 2 over 8 times 13. This is 26 over 8. And then negative 2 over 8 times 1. This is just negative 2 over 8. Okay, so I've multiplied my two matrices. Then from here, I'll move over there. So if I look at this, I have 2 over 8 plus 6 over 8. That's 8 over 8, which is just 1. And then here I have 3 over 8 minus 3 over 8. That is 0. 4 over 8 minus 4 over 8 is 0. And then 6 over 8 plus 2 over 8, that's 8 over 8, which is equal to 1. And I still need to multiply by this 1 over A, 1 over B, and this should be equal to this matrix here. Okay, now this one here, I have 13 over 8 plus 3 over 8. That should be 16 over 8. Which is 2, so I should just go ahead and write the 2. So that is 2. Okay, and this one here, 26 over 8 minus 2 over 8, that is 24 over 8. 24 over 8 is equal to 3. So this is what I have over there. Okay, now this is the identity matrix. What happens to a matrix when you multiply it by the identity matrix is that the matrix actually stays the same. But we can check and see if that is true. So I'll just make some space over here. Let's see if that is indeed the case. Okay, so this is what we have here. Then I continue over there, so I just multiply, do the same thing when multiplying a row with a column. So it's 1 times 1 over A. This should give me 1 over A. And then I have 0 times 1 over B. I add that, that gives me 0, because 0 multiplied by anything gives me 0. And then I have the second row times the first column. That should give me the element in the second row, first column. So it's 0 times 1 over A, this is 0. And then I have 1 times 1 over B, this is just 1 over B. And then this is still equal to this one over here. So this part here is this multiplication over here. So this is a 2 by 2 matrix, this is a 2 by 1 matrix. They are compatible, and you can see my solution is a 2 by 1 matrix. They are 2 by 1. And this is equal to 2 and 3 there. So I'll just simplify this one here. So I have 1 over A and 1 over B. Because 1 over A plus 0 is just 1 over A, and 0 plus 1 over B is just 1 over B, and this is all equal to 2 and 3. Now these two matrices are equal. Remember, matrices are equal if and only if they have the same order. This is a 2 by 1, this is a 2 by 1, so the first condition or the first criteria is met, and then the second one is when corresponding elements are equal. So it means that 1 over A is equal to 2, which implies that A is equal to a half, and 1 over B is equal to 3, which implies that B is equal to 1 over 3. Okay, so these are our solutions. A is equal to a half and B is equal to 1/3. Okay, so when you've got your solutions, you can always check them on your calculator, see if they are correct. Remember the original equations, 2 over A plus 3 over B. This is equal to 13, so we can try that on our calculator. Then instead of A and B here, I will have half, and for B I will have a third. Okay, so 2 divided by a half is 4, and then 3 divided by a third is 9. Okay, then I have 4 plus 9, this is equal to 13. So my first equation is satisfied by A being half and B being 1/3. Then you also need to try it in the second equation. The second equation said 6 over A minus 1 over B is equal to A plus 4 over A. Okay, so again we will substitute the values of A and B. A here is half, so I put half, so it's 6 divided by half. And B is, what is B? B is 1/3. So I have 1/3 there. And this A is half, and that one is half. So I have half here, and I have half there. Okay, 6 divided by half is 12. Okay, and then 1 divided by a third is 3, so I have 12 minus 3, this is equal to 9. And then over here I have half plus 4, this is just 4.5, and then 4.5 divided by a half, this is equal to 9. So you can see my left hand side and my right hand side are equal, so my values of A being half and B being 1/3 satisfy both equations. So I have solved this pair of simultaneous equations by using matrices and finding the inverse. Now you can also do this with Cramer's rule. I made a video on that you can watch and try and solve it using Cramer's rule and then see if you get the same answer. You should get the same answer.